Okay, so today we're going to be discussing this incredibly beautiful explosion that was actually created by scientists a few decades back that for many years remained mysterious. And that's because up until relatively recently, it wasn't actually entirely clear what happened in this case, and more importantly, why this explosion was just a little bit brighter than a typical nova, but much dimmer than a supernova. In other words, this incredibly beautiful event was actually produced by something somewhat mysterious. But in the last few years, the mechanism behind this has finally been explained, and in one of the recent studies, astronomers finally figured out what was left behind. In other words, after years and years of not entirely being certain on what happened here, scientists now know exactly how this forms, and more importantly that this is apparently something that's very important for the evolution of galaxies, and something that's going to happen to at least 1/4 of different stars. And so today we're going to discuss the event that's not a supernova, and that's not a nova, but that's apparently something in between. And in this case, you're seeing the image of the most famous such event, captured by the Hubble Space Telescope, referred to as V838 Mon, the event that started back in 2002 and was then continuously captured for many years to create this beautiful image. And ever since the original discovery, it didn't even have a name. Specifically, we didn't really know what to call these events. At first, they were referred to as ILOTs, or intermediate luminosity optical transients, and that's once again because they were brighter than nova but dimmer than supernova. But turns out that this was basically something that's entirely different and something that's on its own. But because so many more have been discovered since, we now have an actual name for them. They're referred to as red luminous nova. Okay, maybe not the best name, but that's basically what they are. And turns out that these are extremely important explosions for reasons we're going to be discussing right now. And so what exactly is happening here? Well, one of the biggest hints was of course in the color. Because of the very distinct deep red color that usually evolves over months or even years, all of them became known as luminous red nova. And because astronomers now knew exactly what they look like, they were able to find many more in a lot of different places out there. And some of them were even discovered in nearby galaxies, as you can see in this image. As a matter of fact, they seem to be happening pretty frequently, and so this was definitely not something that was unusual. But because they were visible from other galaxies, it implied that all of them were also pretty bright, usually at least a million times as bright as the sun. But not all of them produced beautiful imagery. As a matter of fact, even though some of them did, to date it's really only V838 that created something so spectacular. As a matter of fact, if you try to calculate the speed of this gas as it expands from the center, it's technically moving several times faster than the speed of light, which is of course sort of impossible. But that's because astronomers know that this is a visual illusion. It's actually formed by what's referred to as a light echo. And specifically it's formed by the gas that's already there and that was released thousands or even millions of years ago, that's then stimulated by the light coming from the central star and produces various reflections that arrive to us at different times. And so overall this creates a kind of a visual illusion where it looks like the gas is actually moving very fast. But in reality it's just the light reflection that's coming from different locations in the gas cloud. And so this particular simulation here explains how this works. And that's of course why this explosion appears to grow and even change in shape at an extremely fast pace. But that's not really the part that makes it mysterious. What makes it mysterious is why it produced the flash and why it became so bright. And so what exactly is happening here? And the answer to this question came pretty quickly. Mostly because scientists have also discovered some of the progenitors of these events, eventually discovering that they seem to be binary stars. And since all of them produced very similar emissions and resulted in so much similar events, here the explanation involved a star collision, or specifically a star merger, very likely as a result of a final product from a type of a system we usually call contact binary. And so usually here we have two stars physically colliding and merging into one very slowly, and as they spiral toward each other, they eventually eject a lot of gas around them, producing a huge envelope that's then suddenly illuminated when these stars explode. And so when they finally merge, they create a very specific double peak. A double peak that's actually different in color. The first peak is usually very luminous and blue, caused by all of the initial hot material that's blasted away from these stars, but the second peak is much longer and usually red. This is powered by the hydrogen recombination as all of the gas starts to cool down. And so all of these events have these double peaks and always start as blue, eventually turning red. But as I mentioned, more importantly, these seem to happen quite a lot. But the main reason these events are kind of important is actually pretty simple. And that's because it turns out that a lot of massive stars out there are usually in binary systems. And so studying these mergers is critical because at least 1/4 of all massive stars will eventually produce very similar events and merge with their companions. But because these events take millions of years to unfold, we rarely get to see actual changes and only see the ending. But luckily for us, these mergers happen on human timescales, allowing us to watch a star's evolution right before our eyes. But the other main reason these events are so important is actually because of what you see in the picture. These events are dust factories. Turns out that one such event can eject so much dust that you can actually build 300 Earths out of it. And this is not just hydrogen and helium, this is dust enriched in a lot of carbohydrates and a lot of carbon compounds that we usually associate with life. And so this is a factory of building blocks needed for life, which brings an entirely new meaning to the famous quote by Carl Sagan, "We're all made out of stardust." And this right here is very likely how a lot of it was produced. This seems to be a major source of a lot of carbons. But one of the biggest questions in astronomy for the past couple of decades was actually in regards to the final conclusion. So what's right there in the middle? What's left behind? And since we've seen so many of these events, do they actually end up the same? Or is the conclusion a little bit different every time? So basically, what happens to the star afterwards? Now, if this was a supernova, it would obviously produce a black hole or a neutron star, or sometimes leave nothing behind. If this was a nova, this would be just the result of a white dwarf. But what about a red luminous nova? And that's essentially the main idea behind this study by Righetti, Pastorello, and Valerian. Here they used the famous James Webb Space Telescope to examine 9 specific events from the last couple of decades in order to find out what's in the middle and if it's always different. And so by using the incredible infrared power of the James Webb Space Telescope, they confirmed that these stars do not disappear. They always survive. For example, one of the earliest events from 1997 that happened 31 million light years away from us, and that was actually invisible in optical light, was officially rediscovered by the James Webb in 2024. And here it turns out that this is now an orange giant star. Basically kind of similar to Arcturus and Aldebaran, that are some of the largest and some of the brightest stars in the night sky. And in this case, this is a gigantic star, 120 to 150 times the radius of the Sun. And because it's so large and very likely so massive, it means that this is not the end and actually just the beginning for this star. The star has just been born. Likewise, a separate event in 2011, 25 million light years away from us, produced an outburst that was observed for about 12 years. And here the remnant seems to be surrounded by a very large, cold, dusty shell of amorphous carbon and contains a red supergiant in the middle, kind of similar to the famous Betelgeuse. And so in essence, here the conclusion is that every single time these red luminous nova produce an entirely new object. So these are not terminal events, instead they seem to be the beginning of a completely new life. And instead of destroying the system like in a typical supernova, these two stars combine their mass to form a much more massive single superstar, with a surprising discovery suggesting that many of these stars seem to be much larger than anticipated. A lot of them are classified as supergiants. But despite their mass and despite their large size, they are much cooler than the Sun, with an average temperature of about 3500 Kelvin. That's about 2000 degrees less than the Sun. But the overall, important conclusion here is that what we're seeing behind this beautiful red glow is not a destruction event, but is actually a kind of a cry of a new star being born from the union of two others. So yeah, I'm officially turning this into a Valentine's Day video. This is a love story of two stars that created a new baby. And thanks to the power of James Webb, we've learned that these events create these massive cool giants that will continue to exist for millions of years and will eventually go supernova, finally ending the story in a neutron star or a black hole. As a matter of fact, right now it would be very interesting to find out how many other supergiants, like for example Betelgeuse and Arcturus, have possibly gone through something very similar in the past, because there's a very high chance that many of them were formed in a very similar way. But here this is also a reminder that the universe is not always about destruction. It's essentially a place of constant transformation and constant change, and a place where things sometimes can be born in some very strange ways that we've only discovered in the last couple of decades. But until we learn something else about these events, or until scientists observe another beautiful event like V838, That's all I wanted to mention. Check out some of the previous videos and all of the links in the description below. Thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.